Hi everyone. So today I'll be deriving a special formula from the section formula. So this was section formula. So what is the section formula? That is, you have 2 points A and B, and a point P which was xy, and A was your x1, y1, and P was x2, y2, and P was dividing AB in the ratio m1 is to m2. Then the coordinates of this point was given by the section formula, and this was a derivation when I assume that m1 by m2 is equal to k. Now suppose if the point P is the midpoint of AB, that is if Pxy is the midpoint of AB, then what will happen? Then m1 will be equal to m2, is not it? Then m1 will be equal to m2. That means what? K will be equal to 1. That means K, which is equal to your m1 by m2, that will be equal to 1, isn't it? So the coordinates of the midpoint we can find out in this way. This is the midpoint xy, and k1 means, or m1 is equal to m2, k is 1 means m1 into m1 is to m2 is your 1 is to 1. That is your 1 is to 1 for the midpoint. So then the coordinates of the midpoint, therefore coordinates of midpoint of AB will be what? Let's see, look at here. K is equal to 1, so it is x2 plus x1 by 1 plus 1, that is x1 plus x2, x1 plus x2 by 2. And similarly for here also k is equal to 1, so it is y2 plus y1 upon 1 plus 1, that is 2. So we can write y1 plus y2 by 2. So this is another formula, this is known as the midpoint formula, that is which gives you the coordinate of the midpoint of line joining 2 points x1 y1 and x2 y2 is simply their average, x1 plus x2 by 2 and y1 plus y2 by 2. So this formula, which is known as midpoint formula, this is your, let me write down, okay, let me write down above. So this is your, let me write down section formula, 2 parts, and let me write down the midpoint formula. Midpoint formula, which is a special case of section formula, is given by x1 plus x2 by 2, comma y1 plus y2 by 2. That is, it takes the average of the abscissas of the 2 points and average of the ordinates of the 2 points. So these also are useful. I'm showing you a very good application of this midpoint formula. So now let me erase all this. That you understood how I have derived this from this. So let me erase this one also. This is in general, and for finding out the ratio we take the k form, where m1 by m2 is k. Now this is midpoint formula. Okay, so let me take some example where, let me write down the question. What is the question? That vertices of a parallelogram are given to you. So suppose this is a parallelogram. Say A, the vertices are given in order. The vertices are given 1, 2, 4y. So this is 1, 2. This is 4, y. So this is B, C, and D. And the third one is given to be your x, 6, and the fourth one is given 3, 5. So the 4 vertices of a parallelogram are given in this way. Okay, and find the values of x and y. This is the question. Okay. Question number 2. So you have to find the values of these two unknowns, that is ordinate of the point B and abscissa of the point C. Okay, right? Now, so obviously here we have to first use the properties of parallelogram. So now, properties of parallelogram, you know, the opposite sides are equal. But when we have considered the opposite sides are equal, we have to use distance formula, and you know distance formula is a very complicated expression, square root, this square minus etc. also etc. So we always try to avoid distance formula. So we won't go for that property where opposite sides are equal, because as we have to use distance formula. So instead we use another property of parallelogram. What is that? That is the diagonals of a parallelogram. Diagonals of a parallelogram bisect each other. This is another property. That means AO is equal to OC and OB is equal to OD. That is the meaning. So that means what? O is the midpoint of both the diagonals by the property. So we can use the midpoint formula. So what will you do? We'll find in this way, right? Since the diagonals of a parallelogram bisect each other, therefore what is that? O is the midpoint of both the diagonals, that means AC and BD. AC and BD. So this concept will be using. Okay. O is the midpoint of both the diagonals. This. Now let me take the coordinate of O to be xy. See. No, I cannot take xy because why? Because x and y are already there. So I can't take xy. Okay. So I can take, say, x dashed, y dashed. Okay. So the coordinate of O I have taken to be x dashed, y dashed, just to avoid confusion with this x and y. Okay. Now I'll be using midpoint formula. So O is the midpoint of AC. Right, let me write. Since O x dashed, y dashed is midpoint of AC, therefore by midpoint formula, what we can write, this x dashed will be what? x1 plus x2 by 2. Now I am taking AC. That means this is AC. So this is your x1, 1 is your x1. So 1 plus, and this x is your x2 by 2. I got this. And y dashed will be y1 plus y2 by 2. So for AC, y1 is 2 and y2 is 6 by 2. So how much it is? 6 by 8 by 2 is 4. So y dashed is 4 and x dashed is this. Now when I consider this to be the midpoint of BD, then also we'll be getting the same thing. Also O x dash is midpoint of BD. Therefore by midpoint formula again, this x dashed will be, what is your x1 for BD? This is your BD. So x1 is a 4 and x2 is 3. So 4 plus 3 by 2. 4 plus 3 by 2, that is 7 by 2. And what will be y dashed? y1 plus y2 for BD. y1 is y plus 5. Y plus 5 by 2. So this we get by midpoint formula. Now these are same. So in place of x dash I can write 7 by 2. So this is your 7 by 2. Okay, from this, so this is getting cancelled. So from this what I am getting, take 1 to that side, so x is your 7 minus 1, 6. So x is coming out to be 6. And similarly, y dashed is 4. So here I can write 4. Y dashed is 4. So it gives us y plus 5 is equal to 4 to the 8, or y is equal to 8 minus 5 is 3. So these are the answers. So y is equal to 3 and x is equal to 6. So this is the answer. So using section formula or special form of section formula, that is the midpoint formula, my work became so simple and easy. I have not gone for the distance formula, I have not gone for the other property, the opposite sides of parallelogram are equal, as I have to use distance formula then, and my work will be very difficult and complicated. So I have used the other formula, the diagonals of a parallelogram bisect each other, and then by using midpoint formula, my work becomes so simple, easy. So remember always this method. So this is the utility of the section formula and midpoint formula. Okay. Next question that I have taken, you see, what is the question? Find the coordinates of the points which divide the line segment joining the point A and B into 4 equal parts. That means you have a point, say A here, which is your minus 2, comma 2, and join of this, say this is say B, which is 2, comma 8. So you have to find the coordinates of the points which divide this line segment AB into 4 equal parts. 4 equal parts means first I divide it by half. Here, say this is say P. Then again make it half, say Q. Then again draw the half it, so PQ1. So you see, this is equal to this, is equal to this, is equal to this. So in this, with the help of 3 equidistant points Q, P, R, I can divide AB into 4 equal parts, 1, 2, 3, 4. So that means I have to find the coordinates of the point P, Q, R. That is the question. So now since all are the midpoints, so obviously I will be using midpoint formula. So first of all you find this. P is the midpoint of AB. So write since P is midpoint of AB, therefore coordinates of P will be, what is that, by midpoint formula is the midpoint. I am using this midpoint formula. So A, B, so A is x1, y1 and B is x2, y2 for this case. So that is average of this. So minus 2 plus 2, I can write minus 2 plus 2 by 2 by the formula, and y1 is your plus 2, y2 is 8 by 2. So I am writing directly the coordinates of the midpoint by this formula. So by simplifying, what is becoming? It is 0. Minus 2 plus 2, 0. So this is minus, and it is 5. So I got the coordinate of the first point P, one of the point P. After that you see, what is Q? Since Q is the midpoint of what? Q is midpoint of AP. Therefore, coordinate of Q by the midpoint formula will be, so coordinate of A will be x1, y1 and coordinate of P will be x2, y2. So let me take it. Now what was our P? I found out this is our P. This point is P. So in this case, x1 is minus 2. So x1 minus 2 plus, what will be x2? x2 will be the abscissa of the point P, and abscissa of point P is 0 by 2, comma y1 plus y2 by 2. For A, y1 is 2 plus what will be y2? y2 will be ordinate of the point P. So ordinate of point P is 5 by 2. So what is this? It is your minus 1, comma 7 by 2. So that is the second part also I got. Lastly, the point R. Also, since R is the midpoint of what? R is midpoint of PB. You see, look at the figure PB. PB. Therefore, the coordinate of R be, by midpoint formula, x1 will be abscissa of P. So abscissa of P is 0 plus x2 will be abscissa of point B. Abscissa of point B is 2 by 2, comma, y1 is ordinate of point P. Ordinate of point P is 5 plus y2 is the ordinate of point B. So ordinate of point is 8 by 2. So what is this? The coordinate of R becomes to be then 1, comma, 5 plus 13 by 2. So these are your answers. First point is this one. This is the answer. Then this is the answer, second point, and this is the third point. So this and these are your required points. So the coordinate of the points. So these are the 3 points. We found the coordinates with the use of midpoint formula very easily. So only thing you have to visualize the thing by drawing a diagram. Okay. So that's all for today. Bye.